Today we're going to do the unit on pipe threading and pipe fitting, and I'm going to start by giving you an introduction to this machine. But as in any type of equipment we're using, we always have to know the safety around it. So we're going to start off with safety on this. So the first thing, as if any equipment that we have in the shop, safety glasses, sleeves rolled up. Sleeves can become a problem here just like on a lathe, so we want to make sure that's done. This machine also tends to be a little bit loud and affects your hearing if you're using it for a long period of time. For this exercise, we're just using it in short bursts, so we should be okay. Again, with safety, just like when you're driving your car, the first thing you need to know is where the brake pedal is. You know where the gas pedal is, you need to know where the brake pedal is. On this machine, there's a center position here that is an off position. There's also reverse and forward. We're going to do most of our exercise moving forward. For now, I'm just going to show you this. There's also a safety here as well. So this is where all your operation of your machine is done from. It's from a foot pedal. Just like in a punch press, you always have a foot control or you have a double hand control. This is your safety. You cannot have this disconnected and just move it from forward to reverse. You need it to always have the foot pedal on. Again, with rotating equipment, you want to be careful, keep your hands away from it at all times, except when you need to do a cutting operation. The machine that we're going to use is the Rigid 535 series. Part of the reason we use it is because everything, all your units here that you need to do it, are all in one position. It also has a self-contained well that holds the oil that's necessary to do the threading operation, and it has a removable chip tray. So those are some of the features that we like about this. Looking at the machine here, this is the chuck that holds the piece of pipe that you're going to work on. It's like a collet chuck on a lathe. It has 3 jaws that you can open or close by simply turning the outside ring. As well, when you come over here to the other side, it's got a secondary chuck, and if you got into a piece of material that's, say, twice as long as their headstock here is, you might need to support it. So this again has 3 jaws that open and close in the same manner. The attachments that we have on this machine, we have a cutter for cutting the pipe. Again, there's a sharp wheel on here that does the cutting, so keep your fingers away from there when the machine is running. There's a threading attachment here, so this threading attachment can drop down, and it's got 4 jaws here, 1, 2, 3, 4, and you can open and close them by using this arm. Again, these are for threading, and they are fairly sharp, so keep your fingers away from that. And then finally, the other attachment we have is the reamer for removing the burrs inside. When you're cutting a piece of steel, you tend to make a burr. All of you should know that from using a cutoff saw. Well, what we want to do is we want to get rid of the burr. So in that pipe, if there's a burr in there, it means that it's going to upset your flow, it's going to reduce your diameter, so you don't want to do that. Also, you want to get rid of that sharp edge. So be careful with the pipe. The pipe has, I'll show you a little bit here, it has a sharp edge when it's cut. Do not put your fingers inside this pipe and try to clean it out. Do not grab the thread and try to wipe it off. Always make sure when you get chips, when you're creating their thread here, you're wiping the chips off with this little brush, okay? Better to lose a few little bristles out of this brush than to lose a finger. So this machine has a 3-jaw chuck, similar to what you saw in the collet chuck on the lathe. It's simply 3 jaws, and you turn the outside ring, you turn it counterclockwise to actually open it, and clockwise to close it. On the other end of the machine, there's also another 3-jaw chuck. That's for longer pieces of material. When you have a long piece of material, you want to support it, and that allows you to do that. In most cases, what we're doing today, you're not going to be using the secondary chuck. So there's components to this machine as well. There's 3 attachments that are here. Number 1, this is a pipe cutter. Okay, so it has three rollers here. As well, these can tend to be very sharp as well, and certainly if you get your fingers around this equipment when it's rotating, it's got the capability of cutting you severely. It's also got a threading head here as well, It has 4 jaws here, 4 jaws, and it's very important that they're in the proper location. It also has a reamer here, so when you cut a piece of material, just like when you're cutting a piece of material off in the bandsaw, it leaves a sharp edge. The purpose of this is to take the sharp edge off of it so that the flow in your pipe is not upset by the rigid metal that's left in there. So that's the basic components of it. The carriage on the machine will actually move forward and back manually. Okay, when you're cutting the thread, it will start, you'll use that to start it, and then it will engage itself and take it the rest of it. This is the chip tray here, so always make sure you've got it cleaned out at the end of the day. And inside here, if you look into here, there's an oil reservoir. So it's a self-contained unit, there's a pump in there, and the oil there should always be enough oil in there to do the job. Usually our techs will take care of that. Okay, so at the end of the day, make sure you pull this tray out, get rid of the chips. So now I'm going to demonstrate how to actually create a pipe thread. So we've got ourselves a 4-foot length of pipe. We're going to insert it, always insert it from this end, never from the other side. You're going to push it through to the other side of the chuck until you can see it. What we want to do is we want to extend it about 6 inches only. Okay, 6 inches is ideal. Back on the left side here, we want to close the chuck. We might have to lift it a little bit. We want to close the chuck a little bit just to support the work. And then we come back to the other side, to the original side. All right? When we get over here, we're going to lift it up so it's in the center of the jaws. Bring it towards us and hold the chuck. Hold the material. Just give it a light tap. So, next thing we want to do is we want to cut this off. So we want to cut this off. We're going to put a little mark here. And that's going to be where our cutter is going to go to. Okay? Put our little mark. We want to switch our machine to the forward position. Make sure we have our power plugged in. We're just going to try it and make sure from the foot pedal that it's actually working. So it is working. Okay? The next thing we're going to do is we're going to use the cutter, the pipe cutter. So we want to cut it to this length. So we're going to drop the pipe cutter, make sure that there's 2 rollers here, make sure that the 2 rollers are outside of the pipe and that the wheel is on the opposite. We can slowly bring it up towards it without it running, as long as we don't get it too close. So you want to take up most of that gap there. And then we're going to use the foot pedal and we're going to turn it on. Now before I start, because I'm going to show you this, I want to make sure that you don't turn this wheel in too tightly. We want to make this a gradual tightening. Okay? If we do it all at once, if we jam this thing on all at once, it might break the wheel or it might damage the wheel. Okay, so I'm going to turn this on. Okay, so you ease up on the pedal, let it cut, let the part drop in there, and worry about taking it out after you've got it all cleaned up. So that cut has left a sharp edge on the outside, it's left a sharp edge on the inside. Trust me, it is sharp. So the next thing we want to do is we're going to use the reamer to get rid of that. So the reamer has 2 positions. So this position back is simply to have the access so that you can drop it down. We want to move it to the forward position, so we just push this tab, move it up to here, and now we can access that reamer very easily. Okay, so the reamer's got 4 edges here, and they tend to be fairly sharp. Keep your fingers away from the inside, and you simply use this hand wheel over here to move it forward. So you want to start it, you want to use the wheel to push it forward, drop it back, and keep checking it to make sure that you've got the right depth, that you've cleaned out that burr. So this operation is simply to get rid of that burr. Okay, so we're going to do that next. So just give it a little bit of pressure. And then drop it back. You can move it back into the back position and just carefully check, make sure the burr's gone. So the burr's not gone on this one. So I want to go just do it a little bit deeper. Okay, that should be sufficient. You got about 1/8 of an inch wide chamfer in there, so that should be enough. Now the next thing you want to do is you want to thread this piece of pipe. You don't have to do anything else to the pipe. The pipe die will do it for you. So you simply drop the die down now into position. Now we know this is 3/4 inch pipe, and with 3/4 inch pipe, we've got the right size. So the thread we're creating is a tapered pipe thread, and as a tapered pipe thread, as the two pieces come together, it actually gets tighter. And we use tape, and we use a combination of the taper to actually seal liquids from leaking out of it. So what we have to understand with this is, depending on how far we put the die onto the material, we'll create a smaller thread or a larger thread. So we have to look at a chart to see the accurate way to create this. So this is typical of a chart that you may see, and it's called tapered pipe thread makeup. There's specified sizes on the left side, the nominal pipe size. We're using a 3/4 inch, and we know that the dies that we're using on there are 14 threads per inch. So there's 3 things that we look up here. We look at the hand engagement, we look at the wrench makeup, and we combine the two for the total makeup. Okay, so when you're looking at this drawing here, this is how they engage. So the hand makeup is how tight the thread is, how many turns you can put the fasteners, the couplings. So hand engagement we can check by checking how many turns the fitting fits on the pipe that we just threaded. So for a 3/4 inch pipe, it says we should have a hand engagement of 4.5 turns. And because we have 14 threads per inch, it works out to about 5/16 of an inch. The wrench makeup is how many turns we would attempt to turn it on after we've put the fittings together and put the tape in there. So with a wrench, it should be about another 3 turns after that. So let's go back to the machine and look at the thread that we created and see how many turns we've got on the pipe. So the thread that we've now cut, we want to check, and we want to use that factor of hand engagement and see how many turns a fitting will go in. You should always try to use the same fitting every time when you're checking this. Once you've checked your setting once and you know it's right, you'll be able to take and use it for every other piece you're going to cut. So let's go over here and try this. So we want to simply find the spot where the thread starts. Okay, so we're right there. And we want to count the turns to when we can tighten it up by hand as far as we can. So there's a 1/2 turn, 1 turn, 1.5, 2, 2.5, 3, 3.5, and even though the chart says 3, it should be 4.5. 3.5 to 4.5 is going to be great. So we don't need to adjust our die there. We've got it in a good position. If you needed to adjust the die, you would simply drop it back down again into the position we were before, the cutting position, and then move it. If you needed to make it larger, you move it this way. If you need to make the pipe thread smaller so you have more turns on it, you push it that way. It's as simple as it is. So when you get the pipe threading exercise, what you'll see is you'll see a drawing in here. And this drawing is what you're going to assemble. It shows you all the different components. It shows you elbows, it shows you T's, and it shows you unions. It also shows you over here, you have some fittings, some different types of flares that we use, and a piece of copper tubing. So all these components will be supplied to you. You'll also be supplied with the dimensions from the instructors. So the C dimension will be supplied to you, which is the distance from the center of the pipe to the center of the pipe here. And thinking of it in practical terms, the distance from the center to center is also the same as the distance from the left side of this pipe to the left side of this, or from the right side to the right side. You'll also be given the D dimension, and the D dimension would be the center to center here, and from here you can figure out what length you need to make your pipe. You're also going to calculate here, you're going to use a union fitting, and the union fitting you'll do a calculation here to determine what distance you need to make the pipes as well. So when you look at a pipe fitting has a thread internal to it, and the thread only goes in about ½ an inch, okay? Some, depending on the size, go further. So what we want to account for is we can't simply make the pipe to that dimension that your instructor gives you. We have to make it to a shorter dimension because that pipe only goes in that far, so approximately ½ an inch. So what we have to do is we have to do a calculation to determine how much we have to allow, which is called the allowance, for each of these fittings to get that correct center distance. So we go back to the chart over here, and we have charts here. So these are fitting allowances for T's, 90-degree elbows, and 45-degree elbows. So again, the first column is based on the size of the pipe. So our nominal pipe that we're using is 3/4 inch pipe. And we want to go over to here where it says fitting allowances. So the fitting allowances, we're going to use T's and elbows, and we're also going to use a chart down here for our union. So the union has a different allowance than the T's and elbows do. So if we're looking back to our dimension here on our main chart, on our main drawing, you're going to need an allowance when you're doing your C dimension. You're going to need an allowance for an elbow, and then you're going to need an allowance for a pipe. And there's a simple calculation you go through, and I'm going to let you go through that on your own to determine that. So your instructor gave you a dimension that you're supposed to get to. You've taken your 2 allowances off for the different types of fittings that you're using, and now you've created the pipe that you need to use. So it's somewhat shorter than you started off with. So what we're going to do now is we're going to show you how to fasten those together. Okay, so the first thing you should know is this is a pipe vise. Holding a piece of round material in a regular vise will work, but this is a much more efficient way to use. So what we simply do is we disengage the chain from the one side. You'll notice there's serrated teeth here, and you can put the piece of pipe in here, drop it down. There's pins on here that engage in the base of the vise, and then we simply use the handle to tighten it in place. So the one thing about pipe threading is you need to have pipe tape and actually dope as well. So pipe threading is usually done, we put the tape on it and then we put it with dope. For the purposes of what we're doing, we're only going to do it with pipe tape. So this is a roll of pipe tape, Orange Masters tape, industry standard. We simply start, we find the end of the tape, we put it on, we start at about 1/8 of an inch or 1 turn away from the end, and we always go clockwise. So you can just get yourself a little start here. And we want to do about 5 turns. So that's 2, 3, 4, 5. And just hold the roll and pull it. Now there's an old plumber's trick here. If you take the sharp edge of this and you run it around the threads, you'll seat the threads to make it easier to start and ensure you have a good seal to start, even if you get 4 or 5 of the threads done. Okay? The next thing is we're going to try our fittings on here. So remember we did about 4.5 turns of engagement. We were actually 3.5. So we want to put our fitting on here. Want to start it, and you're just going to tighten it up as far as you can by hand. You know that you had the right number of threads cut. Okay, so the next thing we're going to do is we're going to grab the pipe wrench. I'm going to swing by here. I'm going to grab the pipe wrench. So we want to turn the fitting. So we want to grab it on the raised edge here, the flange of the fitting. We want to adjust our pipe wrench so that it comes down and it's in the throat of the wrench, down to the bottom, and then we're simply going to turn clockwise. So using our size that we had before, we were going to do about 3 turns of the pipe. So let's give this a try. So, one turn, two turns, and that's going to be sufficient in this case. What we want to make sure is that we've got a tight seal. If we over tighten this, what we tend to do is we stretch the fittings, and then the next time somebody uses them, they have to put them on further to make them maintain the dimension. Okay, so that's it for that. To release the pipe wrench, I've just shown a trick where you actually just push down with your thumb on here, and it makes it easier to remove. You've got your piece of pipe, you got your one fitting on the end. Now you want to put the second fitting on the end, and you want to check to see what your measurement is like. So here we go to the other piece of pipe. So we've got it clamped, we've got it turned around, we've got our fitting started on here, and we've got it as far as we can by hand. Okay. So there's as far as we can by hand. So we know we're going to take it about another 2 to 3 turns with the wrench. The secret to this is we want to have everything in alignment. We want everything on the same plane. So a little trick I learned a few years ago is grab yourself a piece of pipe out of the scrap and just put it in here and hand tighten. Okay? You can, if you want, you can adjust it so it's pretty much level or pretty much perpendicular to the ground. And then we're going to tighten this fitting. So you can see this fitting as it is right now is not quite in alignment. So we're going to have to go 2 turns or 2 and a bit turns. So back on our fitting with our wrench, we're going to go 1 turn, 2 turns, and it looks like we can get a 3rd turn out of this one. So we're going to go 1 more. And when we get up close, grab another piece of pipe, start it as well, and we're just going to do an eyeball around this sight line. So when you see that this comes in line with the other one, that's where we want to stop. Okay, so I'm guessing right about there. And the way to check that is you can take it back out of the vise, lay it on the table, and see if both sides touch. You can see this one is a little bit off, so we'll have to tighten one of these fittings to bring it back. So we'll put it back in the vise here, chain back on. And we want to go just a little bit further. Okay. Back out of the vise. Back on the table. So now we're dead level. That's the way we want to have it. And if we start off with our original pieces that way, then everything else will end up in the same plane. And this is at the point where you can check your measurement. If you've done your fitting allowance properly, if you've tightened these to the hand engagement and then to the pipe engagement, the pipe makeup, you should have the same center distance here as what you accounted for. We allowed for 3/8 of an inch difference between them, so if you're 3/8 of an inch longer or 3/8 of an inch shorter, that's going to be okay. You can carry on, do the rest of your calculations, do the rest of your assembly, and then that'll get you to the point where you're ready to do the pipe fitting with the copper tubing. Okay, so we're going to cover that next. So we have to create this closed nipple. The problem is that these nipples will not necessarily have any flat that you can grab your wrench on. So there's an attachment that we use here on the pipe threading machine, nipple attachment, and it's got 3 jaws, 3 positions that you can locate the jaws on. So we want to line it up, open it up, and then tighten it up. And the way that this works is you take your piece of pipe, you thread it in by hand as far as you can, and it comes to a stop inside. So once we've got this in here and we've got it against the stop, we're ready to go. So fully against the stop, we're going to bring the cutter down. So we're going to add about another inch past our threads that are there. We're going to cut the pipe off to there. So let's go through that operation. if you look at this, is that we only have a very small flat on there. So if we were to put a pipe wrench on there, we're going to have an issue. So you use the pin that's supplied and you push it forward, it's spring loaded, and then you can just back your nipple out. So now you've created the final part of our project, with all our fittings now assembled, taped, and ready to go, is to use a piece of copper tubing to complete the project. If we look back to our print here, we've completed all of this. We've put the elbows over here, we've put the T's here, we've put the pipe coupling in as well. The next thing we want to do is we want to connect this fitting and this fitting using a piece of copper tubing. If you notice the drawing, this shows a flare nut fitting, and this shows a compression fitting. So that's the way we connect our copper. Now, I'll show you the two styles here. When we move over here, this is a flare nut fitting. The way to tell it on the outside is it's got a little taper. When you pull it open and have a look, it's got a tapered seat there. So we have to flare the pipe to match that seat. So that's that fitting. This is the other type of fitting. It's called a compression fitting. If we take it apart and look at it, we have a taper in here. We have what's called a ferrule, and then this is the nut for it. So we'd simply put the nut on the piece of copper tubing, slide the ferrule onto it, and then slide it in as far as it would go into the fitting. And we bring the nut up, we start tightening the nut. The general rule in these is you tighten them up hand tight plus about 1 turn of the wrench, okay, after tight. All right, so we're going to talk next about how we actually calculate our bends in this. Keep note of the fact that if you're doing this in reality, you're probably going to use dope on these fittings. You don't really require to have tape on these, but if you're doing them in industry, you would be having dope on them. For our application, we're not going to tape these. The first thing we want to do is we want to cut a piece of copper, and we want to get it to the right length. We'll leave it a little bit longer just to try and get it so that we have some extra in case we made it look a little boo-boo. So what we want to do is we want to come down here and look at how much copper we need. So our fittings are out to here. We need to go at least the center distance to here, and then the distance from here to here. We don't have to calculate for the bend. We'll show you how to do that later, but we don't have to calculate for that. We just got to get an approximate distance. So for this application, we're looking at about 8 inches this way, and then holding it into the bottom of the fitting, we're looking at about 6 inches this way. 8 and 6, 14. I would add 2 inches to the length of copper that you're going to cut. So the next thing we want to do is we want to get our piece of copper. We calculated it to be 16 inches. So we take it from a roll. So copper comes on a large roll. You want to straighten the piece out that you need. So I usually, as a rule, I'll put my hand down here and I'll just slowly unwind it a little bit, keeping it pressed against the table. That way. Okay, we can take out this little kink at the end afterwards. Bring your tape measure along, put it on, measure out your 16 inches, mark it with a marker. Okay, we have a tool here. It's a little version of the pipe cutter like we had on the pipe cutting machine. You can open it up, it's a rigid brand again, and then we simply put it on between the two wheels, tighten it down a little bit. This is particularly important that you don't over tighten this. Copper is fairly soft, and what we tend to do is if you tighten it too much in one shot, it will actually distort the shape of the copper tubing. So what we want to do is we just want to put it on a little bit, give it a couple of spins. Usually you pull it towards you, tighten it a little more on the nut, give it a couple of spins. Don't be in a rush to do this. Another little bit. And eventually it will break. Okay, so what you'll see here is you'll see, just like when we cut the pipe, you'll see a little bit of a burr on the inside of here. Here's where you want to take your hand tools, take a nice little round file. Sometimes these tools will actually have a little deburring piece on there. These ones don't. I just take a file and just gently go over the inside of it, get the burr off. Okay, if you don't take that burr off, what you'll tend to do is you'll create a seat in your flare nut fitting that is not going to be a perfect shape, and you might have a bad seal. The next thing we're going to do is we're going to flare the fittings. So this is our flaring tool. Okay, this is what it looks like all assembled. If we take it apart, we can unthread this, slip it out, turn it to the side, and you'll see there's different numbers here of the different sizes of tubing that we're using. We're actually using a 1/2 inch tubing, and a 1/2 inch tubing is there at the end. If you look at the inside of the jaws on these, you'll see they're serrated. So there's serrations. That helps you grab the tubing so that when you're putting this flare on, it doesn't move. Okay? What you'll see on this side is all of these sizes here have a taper, except when you get down to 1/2 inch. On a 1/2 inch, the flare is on the other side. So that's where you're going to create it from. So we want to simply place our tubing in, the end that we deburred, push it through, and line it up flush with the edge of the jaws. Using the wing nuts, we want to start this end, and we want to tighten this down as tight as we can get it. For all intents and purposes, these two pieces should be together and should be parallel. Okay, and then you can tighten down the other side. Then we want to insert our anvil on here. So we put it on, we bring it over to the edge, insert the tapered plunger in there, and start tightening it up. And what it's going to do is it's going to create a flare that matches where it attaches to on the fitting. Okay, we'll loosen it back off again, and we want to inspect it. So we've got a nice flare on there. It looks like it's going to be enough. The one thing that you could run into, and I didn't account for on this, is that in some applications you may need to put this nut on first. If you didn't put the nut on, you might not be able to get it on. But for what we're doing here, we're able to slide it on. So simply loosen this off, both ends, open it up, and voila. You have your taper in there that matches the fitting. Okay, and now I'm going to show you what I do to assemble. The next portion of this is a trial fit. We're going to have to actually calculate how far, we're going to have to mark how far we're going to cut this pipe and where we're going to do the bending. So the next thing we're going to do is we're going to do a trial run here. We're going to assemble, this is our flared fitting that we just created. We're going to bring it up. I'm going to tighten it up by hand as far as we can go. And then we're going to eyeball. We're going to eyeball this fitting and try to get so that we make a mark that's in line with here, the center of the fitting. So that's our first mark. Now, because the bender that we're going to use has got a radius on it, we know that the radius is about 3/4 of an inch to an inch. So let's put a mark 3/4 of an inch back. Okay, so that's our mark. So that's where we're going to start our bend, and then we're going to bring it around, and with the radius that we have, it should end up bringing it nice and in line with here. So this is our tubing bender. It's designed to use 2 hands. I find it's easier to take this bender and mount it in the vise so that we can do the job easier and we don't have to have that extra hand in there. So the 2 marks that you've got, the one that's closest to the nut, what you want to do is you want to have that mark line up with the 0 here. Okay, so in order to start this, you want to make sure the handle is up here and that the clamp is off. You want to set this on the 0 mark, and then you simply clamp it on like that. You move the handle, turn the handle a bit, and you want to line the 2 zeros up. Okay, it's important you line the 2 zeros up. That way you get a nice smooth bend. And then you simply grab the end of the handle over here, and you're going to bring that 0 around to the 90-degree mark until it lines up. So here we go. 45, there's 90, okay? And there's a little bit of springiness there, okay? And now we can remove it, flip the clip, give it a little wiggle, pull it out, and now you've got a nice 90-degree bend. We're going to take that over and we're going to do one more measurement and then finish it off. So we've got our piece bent up here. We're going to bring it up here. We're going to do a trial test run on here. Start it on our flared fitting. Okay. And if everything came out right, this end of the leg should end up in the center of our fitting, and it does. Okay. So now it's too long. So what we're going to do is we're going to mark where the threads end, close to the hex part. We're going to mark it here, and we're going to cut it off to there. We're going to deburr it a little bit, and then we're going to put it back on here, and that should be the last step. So the final step, take our tubing cutter, bring it over to where the notch is, the black mark that we put on there. Make tight down, make sure it's in the 2 rollers. And again, little cut. Not applying too much pressure, letting the cutter do the work. Cut it off, and again, take our file and clean it all out again. And then we're going to go over for our final. So here's your chance to actually check this out and make sure it fits right. Just going to insert this into here. And it looks like it's the right length. Everything's good. So that's our dry run. So now we're going to take it back off again. Going to insert the nut first. Okay. Slip the ferrule on. I always like to put this end in first and just get it started. Now, one of the keys to this is you want to make sure that when you're tightening this down, the pipe ends up square to the fitting. If it's on an angle like that or that, what tends to happen is you end up with an air leak. So we're just going to snug it down a little bit, start this fitting over here. Okay, and then you can tighten this down to hand tight, and then about a 1/4 turn. That's enough for there. Take this one, push your tubing in, tighten the ferrule up, hand tight. Okay, and then, like I said before, you're going to tighten it about another 1/4 turn. So that should give you a leak-free piece of copper tubing, and then you can finish your project off.